Welcome back to the deep dive. So let's just jump right in. If you're running automated processes right now,
Things like trading signals, logistics planning.
exactly, supply chain optimization, anything like that, you're already dealing with agents. But the next massive leap, the one everyone's talking about, involves those agents talking to other AI agents.
Across different companies, across boundaries.
Yeah, and that kind of shift, it requires real infrastructure. So today, we're doing a deep dive into Project NANDA. That's NANDA for Networked Agents and Decentralized AI. It's coming out of the MIT Media Lab.
And their proposal is pretty bold. They want to build the foundational protocol layer for this whole future Internet of Agents.
Okay, but that immediately brings up a huge tension, right? We already have so many standards floating around. We have MCP, which is your internal plumbing, connecting your agents to your tools. We have A2A for agent-to-agent talk, but usually within, tight, pre-agreed boundaries.
Right.
So the big question, and this is coming from industry leaders like Professor Ramesh Raskar and Mr. Ashish Chauhan at NSE India, is pretty simple. Do we really need another new complex layer like NANDA?
And that is the exact mission of this deep dive for you. We need to cut through all the jargon and figure out if NANDA is, the necessary ambition we need to scale a global agent economy, or if it's just overreach.
Adding complexity for no good reason.
Exactly. We're looking for the gap that NANDA actually fills.
Okay, let's unpack that. I think we should start by just establishing the problem NANDA is trying to fix. The sources, they describe the current agent world as fragmented, siloed,
And dangerously proprietary.
yes. If you're running these systems in your organization, you see this every single day. I mean, think about it. You might have a really sophisticated financial agent that's amazing at pulling data from, say, NSE India's APIs.
And generating signals from it.
Right.
Right.
But that agent is basically locked inside your own systems. Meanwhile, some other hedge fund has their own arbitrage agent that's hardwired into their broker, maybe through a zero-to integration.
And these agents, the research calls them, it says they live in proprietary micro-universes. They're built to talk to their owner's data and their owner's systems, and that's it.
So if my agent A needs something from your agent B,
A developer has to get involved. They have to write a custom one-off integration, handle APIs, proprietary keys. It's a whole thing. And that just doesn't scale. I mean, if we're really moving to a world with millions of these autonomous systems.
negotiating deals, delegating tasks.
Yeah, exchanging data securely. We can't have human developers building a custom bridge for every single interaction. We're just building more walled gardens, not an internet.
That sounds terrifyingly like the early days of the web, before we all just agreed on things like TCP/IP and HTTP.
Precisely. And that's why NANDA identifies 4 foundational issues that, they believe have to be solved to get to a global autonomous agent economy. The first one is discovery. How does Agent A even find Agent B out there in the wild?
Like a phone book for bots.
Kind of, but way more advanced. NANDA proposes a decentralized agent registry. It's a secure, open way to index agent identities and what they can do. It's really the DNS for agents.
Okay, but hang on. If the whole registry is decentralized and open, what stops a malicious agent from just spoofing a trusted identity? The DNS analogy feels a bit too simple when there's real money and data on the line.
You're right, and that's where the second pillar comes in, trust and verification. This is what takes it beyond a simple DNS. NANDA uses cryptographic identity and verifiable credentials. It's pulling a lot from established standards like W3C DIDs.
Decentralized identifiers.
Exactly, and this is so crucial. It's not just like an SSL certificate. It lets an agent representing, say, a major bank cryptographically prove that claim without needing to check with some central NANDA server.
So the verification is baked into the identity itself.
It is. That's what stops the spoofing and secures the transaction.
All right, so we can find each other, we can trust who we're talking to. What about the actual conversation? What language do they speak?
That's the third pillar. Coordination in transaction protocols. Agents need a shared, secure language for all this stuff. Negotiation, data exchange, payments. NANDA is building these open protocols. Think of them like HTTP and REST, but built specifically for how agents behave. So these protocols, they'll have built-in functions for things like state reconciliation, complex negotiation, even things like atomic swaps or micropayments. It's way beyond a simple API call. It's true, secure, peer-to-peer delegation.
And the fourth one, the one that feels like it connects back to that early internet idealism. Decentralization and ownership.
That's the one. Because if we don't build this open layer now, the whole agent economy could just get centralized under the huge platforms.
Google, OpenAI, Anthropic.
Yep, the ones hosting the foundational LLMs. If they control the identity, the registry, and all the access points, they become the toll booth operators for the entire future of automation. NANDA is trying to build that escape hatch.
That framing really makes the need for NANDA seem urgent. But let's get practical for a second. When does this complexity actually become worth the overhead?
That's a great question.
Because if my whole setup is internal, adding all this extra plumbing just sounds like a huge headache.
And you're right to be skeptical. If your agent setup is closed, if it's self-contained, then yeah, NANDA is probably unnecessary overhead for you today.
So what does that closed loop look like? Give us an example.
Let's go back to the one you mentioned. You have a custom NSE options agent. It's pulling data from an internal server. It sends signals to a zero-the bridge. That whole loop is tightly coupled.
We trust all the parts because we built all the parts.
Exactly. They operate inside your security perimeter. You don't need global discovery or decentralized identity for that.
So NANDA stops being this abstract academic idea and becomes essential the moment you step outside that perimeter, when you need to trust someone you don't actually know.
That's it, precisely. The critical moment is interoperation beyond your organizational boundary.
Right.
So, for instance, what if your agent needs to get data from some external global volatility index agent run by a research firm you've never worked with?
You'd need to verify it's legitimate.
Right. Or maybe you want to monetize your own trading signal. You want to expose it as a service that other autonomous bots can discover, verify, and pay to use. That's when NANDA becomes essential.
Okay, that clarifies the difference between all these acronyms. So MCP and A2A, those are your internal mechanisms, the pipes inside my building.
And NANDA is the public infrastructure. It's the global address book, the DNS, and the verifiable security layer, the SSL and DDs, that let all those external high-stakes transactions happen safely without a human in the loop.
All right, let's weigh the scales then. I want to hear the best case for NANDA as pure ambition, and then the strongest arguments for why it might be premature overreach.
Okay, starting with ambition. The case for NANDA is really robust, but only if you accept one big premise.
Which is?
That agents will become as ubiquitous as web servers are today. If you believe that's where we're headed, then NANDA is simply a future-proof architecture.
It's a non-negotiable requirement for that scale.
Exactly. You need the equivalence of DNS, TLS, and a public key infrastructure for it all to not fall apart.
And it tackles that centralization risk head on.
Yes. The push for an open, vendor-neutral network is a huge part of its appeal. Without it, identity and discovery just default to the big platform owners. That creates a massive single point of failure and control. And you can't ignore the academic and ecosystem credibility. It's backed by MIT Media Lab, which brings a lot of rigor. And it's not trying to reinvent the wheel. It explicitly builds on existing standards from Web3 and the W3C.
That's a really compelling case for why we'll eventually need something like this. But let's bring it back down to earth. Why would a developer or an organization today say no thanks? The most obvious hurdle is just timing. Is this all premature for today's market? I mean, if 95% of agent deployments are still closed systems, this global discovery layer just feels like friction we don't need yet.
That skepticism is totally valid, and it feeds right into the crowded ecosystem problem. Developers are they're tired.
Protocol fatigue.
Yeah, protocol fatigue. They're already juggling A2A, MCP, GraphQL, Web3. Asking them to integrate another mandatory layer, especially a complex one, is a tough sell, which leads you straight to the classic network effect barrier. NANDA's biggest value proposition is discovery. But that value is zero until a critical mass of useful, verified agents actually joins the registry.
It's the chicken and egg problem.
The ultimate chicken and egg problem for infrastructure. Why should I join if no one's there?
And finally, the one that always seems to derail these beautiful decentralized systems, governance. We all love trustless systems until, a bad actor shows up. What happens when a legitimately verified agent, say, from a big brokerage, starts broadcasting toxic or malicious data if there's no central NANDA authority who steps in? How do you revoke an identity?
That governance complexity is, I would argue, the single hardest challenge NANDA faces. It's not enough to verify an identity once. You have to define how you handle trust revocation, dispute resolution, all without a central referee. The system has to have built-in ways to flag or blacklist bad actors, otherwise the whole trust model falls apart. So, where does all this leave us? I think NANDA's success hinges entirely on timing and adoption. Right now in 2025, maybe into 2026, most agent workloads are going to stay closed and internal. NANDA will probably feel like a heavy academic blueprint for a while.
But the sources seem pretty clear on the inflection point. They're pointing to 2027, maybe 2030. That's when organizations are expecting to deploy entire fleets of autonomous systems that absolutely have to talk to each other across company lines.
And that's the moment NANDA's model goes from being an ambitious idea to being essential infrastructure.
So if you can get a critical mass, even just a few thousand high-trust agents and services to start, it could become that DNS plus SSL for the agent web. It could enable these open, secure agent economies that we can only really dream about today.
And that really leaves us with this final thought for you to consider. The Internet of Agents, it's coming. It's inevitable. And it will need its foundational layers, its DNS, its SSL, its search engine for trust. The real question isn't if we need this infrastructure, but who ends up controlling it. What are the long-term risks if the same giants that control the core LLMs also become the gatekeepers for identity and communication? The entire future of open automation might depend on whether projects like NANDA can get this decentralized foundation built before it's too late.